This is from the Kennesaw State University Math Tournament for high school from 2019-2020 school year. Let P, Q, and R be the roots of this cubic equation, x cubed minus 14x plus 29x minus 4 equals 0. Compute the value of the expression 1 minus 1 over P, 1 minus 1 over Q, 1 minus 1 over R. Now going back to the previous problem with the quadratic, there wasn't a simple way to evaluate something like this. So we'll need to use a little bit of manipulation to get the answer. First, let's figure out the Vieta's equations for cubics. In a cubic, our solutions will be, if they were a, b, and c, we have x minus a, x minus b, and x minus c equals 0. And if we expand this, we will get x cubed minus a plus b plus c x squared. Now for if there's one x, we have ab or ac or bc, and the two negatives cancel out, so we have plus ab plus ac plus bcx, and finally we have minus abc equals 0. Now notice from the previous one with the quadratic the difference. In the cubic, product is the opposite, it's the negative version. In the quadratic, the product is the sum. How do you know the order? Well, it's always positive, negative, negative. If it was to the fifth power, it'd be the fifth power would have a 1, then the fourth power would be minus the sum, and the third power would be positive, etc. So we can use this. Now, we need to manipulate this so that we get a familiar form. First of all, we don't like these expressions, 1 minus 1 over p. So let's turn it into p over p minus 1 over p, q over q minus 1 over q, and r over r minus 1 over r. And now we can combine with the denominators, p minus 1 over p, q minus 1 over q, and r minus 1 over r. And since they're fractions, we can multiply the numerators together and multiply the denominators together. I'm going to put that over here. So we have p minus 1, q minus 1, and r minus 1 divided by p, q, r. Look at that. We have the product of the solutions, which we can figure out. In this case, what is our product? The product of the solutions would be 4. So let's go ahead and note that p, q, and r equals 4. And while we're at it, let's note the other things too. We have plus ab plus ac plus bc for the x term, and we have a plus 29x. So we have pq plus pr plus qr equals 29. Then we have a minus a plus b plus c x squared. And we have a minus 14x squared. So we know p plus q plus r must be 14. Great. Now we don't have p, q, and r up here. We have p minus 1, q minus 1, and r minus 1. So it's not exactly in the form we want it yet. Since they're multiplied, let's go ahead and expand it and see what we get. We'll take p, q, and r, and have the product. Then we'll take p, q, and minus 1, we'll have minus pq. Then we'll do p minus 1 and r, so that's minus pr. We'll have p minus 1 and minus 1, so that's a plus p. Then we can go into minus 1, q and r, it's minus qr. You can have minus 1, q, and minus 1, so that's positive q. Then we can have minus 1, and r, so that's a plus r. And finally we have a minus 1, minus 1, minus 1, so that's a minus 1. And this is still divided by p, q, r. So we see some things like pq and pr and pqr that we like. So let's see if we can group those together. This equals pqr minus, so there's a pq, qr, and pr, and they're all subtracted. So I'm going to factor out a negative, say pq plus qr plus pr. and we have a plus p plus q and plus r, so we'll add it onto the end. Then we have a minus 1 divided by p, q, and r. Now look at that. These are in the form that we want them to be. So now we can simply plug them in. PQR we know is 4, so we'll have 4 minus. This is equal to 29. This is equal to 14. And then we have the minus 1. And of course PQR is 4. Now this simplifies too. 4 minus 29, that's negative 25. Plus 14, well that makes negative 11. Minus 1, well that makes negative 12. And divided by 4, and we have negative 3 is our final answer. Now for this one, you didn't have to solve the cubic, and you probably don't want to solve the cubic, but you can still find the answer using Vieta's formulas and a little bit of manipulation. That's all.